Meetup will start now. Okay, so we should be going live soon, and I'm admitting participants as well.
Hello, hello. It's filling up. That's cool.
Hello, everyone.
Hello.
Hey.
Hey.
$32 already.
There should be 36, so 4 more people are joining.
Yeah. And some people I know. That's cool. Hi, Christian.
Hi, Peter.
Yeah, cool. You kind of brought your whole fan club with you. That's cool.
Yeah, I need some support. I think
Yeah.
Friendly crowd is really makes this easier.
Yeah.
40. Nice.
I think there was 69 in the meetup. So I'm hoping to go above 50, which would be a good show up for, like, you know, an online event, which you usually you just click and then you forget or something. Yeah.
Yeah, exciting stuff. Hey, are you still doing these quarterly meetings at the moment with all the lightning talks?
I mean, at the moment we did no meeting at all. So this is the first meeting since more than 12 months. So, but otherwise, we are open for different formats. Like, if people say like they have only something small, then we do lightning talks, right? And then we do 1 or 2 together. Yeah, we're quite flexible on this side. So it depends what people want to do, what they can offer, and yeah, then we try to find a way to do it, because, you know, there's small talks and there's bigger talks, and they should all find their place, right? Yeah.
All right. See, there's a couple of guys in the chat who have questions. I'm not sure if somebody's already addressing that.
Chat questions. Actually, no, I don't see.
Hi, everyone.
There's
Just
a chat
joining.
on there. Okay, Sebastian, can you hear us now?
Hello from Hamburg to Uruguay also.
Okay.
Wow, it's pretty international. Didn't expect an international crowd here at this level. Uruguay must be, what's the time zone?
-5 at least, or
Okay.
6 hours.
Malte, maybe you have to do the chat stuff, because I don't see anything.
Yeah, I can collect also some questions for you maybe later.
Yeah.
At least support you with it.
Yeah. Thanks.
Yeah.
Weird.
Yes.
Okay. It's 5 minutes after 8, so it's 20:05. We promised to start now. So hello, everyone. Nice you all found your way here to the Hamburg RUG user group meetup, which we did not do for more than 1 year. So I'm very, very, very happy that we managed to do it now. So which basically means I'm very happy for Daniel Brandt that he reached out and said, hey, I'd like to do a talk. How about me doing a talk? And we said, yeah, sure. That sounds amazing. And also, thank you very much, Malte, for doing the heavy lifting on the organizational stuff, and of course for the YR people for setting things up and including us in the pre-meeting series of YR. Thank you very much. Most appreciated. Super cool. And thanks also to our sponsors, the R Consortium, the Job Match Me here in Hamburg, Jumping Rivers, Virtual 7, and YR, obviously. Yeah, today we will have a talk done by Daniel Brandt. Daniel Brandt will talk about a trading research system done in R. So he's from SSW Trading. It's a heavy user of R, and I'm very, very excited what he will talk about, what he will show us, and what we can learn. So after I'm done, Daniel will be able to start, and then he has something like 45 minutes. So we will have the talk until 20:55 approximately. Then we will have a break because breaks are important. And then there will be time for questions done coming from the crowd, as well as maybe some broader questions about the company or some broader things about the things Daniel does. So this is then called Meet the Expert. And after that, we will stop the recording, and the official part will stop, and we can still meet here to have a cool down beer. So for your information, this is recorded, and I think now it's time for Daniel to take over and start. I'm very, very looking forward to it. Daniel, it's your turn.
All right, thanks a lot for the introduction, Peter. Thanks a lot for having me. I'm very excited about the work we do with R, and sometimes it's really nice to be able to show it off. And yeah, so thanks for organizing this also during the pandemic. Yeah. Okay, so I want to show you some stuff that we're doing with R and the research system we've built with R and around R that we use basically to enable our analysts and our researchers to improve our algorithms and ultimately try and make the company more profitable. But first, so the talk will consist of basically two parts. In the first part, I will sort of try and give you an impression of what it is that we've done, what this research system that I'm talking about looks like, how this integrates in into our IT ecosystem, how we talk to the various subsystems, what technologies we use, how this all plays together, and how we've managed to build a professional sort of quality assurance and release cycle. And in the second part of the talk, we'll do some live demos, and I'll show you my R console, and we'll do some stuff live. But first, the question is, oh, now my slides don't want to switch. There we go. First, I want to talk a little bit about what my company actually does and how we earn money. So I'm with SSW Trading. This is an algorithmic trading company, which basically means we trade different kinds of assets, stocks, bonds, ETFs on different trading venues, different stock exchanges all the way around the world, and we trade these with algorithms. So we have an objective mathematical decision-making process that decides whether we want to do a trade or not. There's no human sitting there going, nah, it's raining, I think Google is going to go down and BMW is going to go up. We don't have that. We have algorithms, we have mathematics, and we try and have an objective decision-making system that decides whether to do a trade. And what we are also is we are a proprietary trading firm. So there's no third-party investments or clients. We do not. You cannot go like with, for example, like with a hedge fund and go, okay, I want to invest $1 million into SSW Trading. We only trade with the company's own capital, and that is something that's always very cool to point out, because it's the best proof I can give you that our algorithms actually work and actually make money, because otherwise we'd all be bust. There is no money coming in from anywhere else. And so with the company, we managed to trade maybe 30,000 different financial instruments every day in 30 different exchanges all the way around the world in 5 continents. And we're doing this with about 100 employees. So that's very, very exciting to me. We're really part of the global financial system, and we're really participating. And we're doing this in an almost completely automated way, which is very exciting to me. And for the question how we earn money, you basically got to know what a limit order book is. So if you don't know an awful lot, if you haven't had an awful lot of contact with brokerages and stock trading, you might think, okay, I can go to my bank or my broker and I can say, what's the price for, say, BMW? And they will tell you the price for the stock. That's not really how it works. Really, there's 2 prices. There's what you pay when you want to sell, when you want to buy the stock, and there's what you receive when you sell it. Yeah, you know this maybe from exchanging money. Yeah, if you take your money to an exchange place, you swap your euros for dollars and you swap it back. Afterwards, you have less money than you started with. And this difference in price between the buy and the sell price, or we call it the bid and the ask price, arises from the limit order book. So basically, anybody can go to the stock exchange and can say, well, actually, I am willing to buy 100 shares of a certain company for $99. And somebody else might go and say, well, I'm willing to sell you my 120 shares for $101. And somebody else says, well, I'm willing to buy it for 98. And somebody else says 98. What a good idea. I'm also willing to buy for 98. And thus, bit by bit, an order book is created and a system of bid and offer prices is created. And you see in the system of bid and offer prices, there's a gap between the best bid price, which is what people are willing to pay, and the best ask price, which is what they want from you in order to let go of their shares. And this gap is called the spread. And this is when if you would go to your bank and say, I buy 100 shares of company A, and now I sell them again, then you have less money than you had before because you've paid this spread. And this is a concept that you're already familiar with from going on holiday. This is basically what you do when you exchange money for going on holiday. They tell you, oh, no commission, no fee. That is true. That is because they earn their money from the spread. That is because otherwise, if they wouldn't do that, there wouldn't be anybody running an exchange shop. You would have to run out to the marketplace and say, who wants to give me dollars? I have euros. And that would take an awfully long time. It would be very complicated. So this is basically, effectively, that is the fee for the person who provides your liquidity, provides the money for you going on holiday, who provides the foreign currency. That is exactly what we do. We provide liquidity. We do market making. We post orders that we're willing to buy and sell most stocks. And then when one person sells us something and another person buys it from us, then we earn the spread. And that is how our company makes money. And so to us, there is not one price, like to most people in the business, there is not one price of a stock, but there's 2 prices. There's the best bid price and the best ask price. And so if I plot this throughout the day, this is just one instrument on the German stock exchange. You see here the best bid price and how the best ask price change throughout the day, how this gap sort of changes a little bit. But also this gap is very, very small compared to the actual price of the instrument. So if you want to earn this spread, then you have to be very careful that you only do the right trades. Otherwise, you can lose money very, very quickly here. And so in order to make sure that we choose the right moments to buy and sell certain shares, we have our research team and our analytics team, and we have built a trading research framework, and we've built this in R. And this is something I'm very excited about, because this is something that allows us to use a very expressive language, a language that's very easy to understand, very easy to grasp, with a very nice grammar, and to really do exciting work with it. And so to show you what that looks like, of course, here I'm showing you sort of the ecosystem of tools and packages and languages that we're using. And you see a lot of languages on here that are in R at the bottom layer. And the reason for that is, of course, that any big software project these days isn't written in one language. If you say, I'm building my website in Python, it's like, well, no, you're not. You're building the back end to your website in Python, and the front end is probably HTML and JavaScript with some React thrown in. You're using a SQL server or a MongoDB server for your database, and you run it all on Linux, and there's a whole bunch of different tools written in all sorts of languages that you're using, but you have one main language that you're using, and that is R for us. And besides that, so I'll just go from the bottom. We have this implementation layer where basically the philosophy is use the best tool for the job. So for example, we have XGBoost, which is a great library for building boosted decision trees, very robust machine learning. We have Python, which is written in C, of course, or C++. We have PyTorch, which is a Python library. We use for sequential processing. We use all sorts of things like RCPP, Armadillo. There's a lot of code that's written in C++ and Python. And on top of that sits an abstraction layer, which basically provides consists of proprietary R packages, which sort of wrap all the complexity and abstract this away and give you a really nice sort of unified look and feel for interacting with all that complexity. And on top of that, again, is what we think of as the research layer. These are packages that abstract away even more of the differences and complexities and sort of give you a really nice, easy to use tooling. So for example, I have a data loader package on top, which makes sure I can get data out of 20 or 30 different databases. I never have to worry about where these databases are, what the different IP addresses or ports are to talk to them, whether it's MySQL or some NoSQL system. Yeah, this package just handles all of this for me. There's a pipeline package, which encodes our machine learning pipeline. And there's also the flex table package, which is a very powerful data analysis tool, which we'll meet a little bit later in the talk. So this is really how we use R to orchestrate our research system. And if you have all of this complexity, one thing, if you build anything complicated in R, one thing that is very important and that I would recommend to everybody is to have a very disciplined build and release system. Because the worst thing that can happen to you is if you have 10 different proprietary R packages in your organization used by 20 different people, you work on your package, you make some changes, you compile it, you think it's great, and the next morning everybody else can't work because it doesn't play well with one of the other packages. That would be awful. So we have a very nice sort of CI/CD pipeline. We're using Git for our version management. We've set it up so that if you want to I sort of assume most people have heard of Git. Yeah, you can keep all your changes to your project in branches, and at some point when you're done, when you've implemented some changes, then you can merge this branch into your master or your production branch and take it to productivity. And you cannot do this merge in our system without the unit tests running. So as soon as you submit a merge request, automatically the unit tests start. Only once the unit tests are complete, you can even begin to merge and have a merge review. And when you then want to release the package, everything is merged into your production branch, and the pipeline starts. We have a GitLab runner that is scheduled to run once a day in the evening, and it starts by basically using R to compile the package from source, creates a heap of build artifacts. It uses Roxygen, which I guess most people who build R packages have heard of. This is the R implementation of the popular Doxygen package for automatically documenting software APIs and generally software frameworks. And here you can, in R, you can use it. You can use decorators with all your functions, and then automatically it generates you the nice help files for R, all the PDFs, the man files, and it also manages your namespace exports and stuff like that. And so everything is Roxygenized. Unit tests are run. Sanity checks are run on file sizes, namespace bindings, etc. And then in the end, if everything is successful, Git also deploys the finished package to the target library. And what you don't see on here before it does that, it runs in integration tests with all other packages in the ecosystem. And I can very highly recommend making the effort in R if you ever work with packages, especially with more than one package, to build yourself a pipeline like that. I would very highly recommend using Roxygen and using TestStat to build unit tests. It saves you a whole heap of trouble in the long run, in my opinion. Yeah, Peter smiles. He knows exactly what I'm talking about. Yeah, a lot of this I've picked up from Peter and Christian, of course. So okay, so we have a lot of packages. We can build them. What else do we need? We need data. We're data scientists. We need data. And when you're in the stock trading or shares trading, automatic trading, there is a whole lot of data that is generated all the time. Yeah. In the past, we used to record all the data from all the exchanges where we were connected and where we had feed data. We used to collect all of this into an SQL database, for later analysis, and we would easily write 1.5 to 2 terabytes a day to SQL databases. And that way you run out of database space very, very quickly. We have something very much nicer now. If you ever see this abbreviation colo, this is common in algo trading. This means co-location. So this means we have a server that is located with the exchange in the same building as the stock exchange where our strategies run, and this same server also records data from the exchange. All the data that the exchange sends us, it records. It uses a Kafka stream to send this all into the cloud, and we use the Amazon cloud. EC2 is the Elastic Compute 2 cloud from Amazon, and we store the data there basically as flat files in an S3 bucket. And then the question arises, how do you ever get this back into R? And the answer to that is we have a nice RESTful API. We've got our own package that loads us back, and I will show you later how nice and easy and well integrated you can get this to load this data into R. And in this way, I mean, if you have a database server is very expensive. A database server in the cloud like this, you can very quickly spend 50,000, 100,000 euros a year to run a big database server. With this, you're at maybe 1% of that cost. It's a lot cheaper than database servers. And you don't have all these maintenance problems, what if you have too many lines, auto vacuums, etc. All that you don't have to deal with, but you once have to build your APIs for this. And in this way, we can, before we were somewhat limited with how long into the past we could go. Now I can go back indefinitely. All the data we ever record is immediately available to me. Nobody needs to go and change a magnetic tape or anything. And that is something, of course, to a data scientist, everybody knows between the team with the better scientists and the team that has more data, the team with more data wins. And that is very much the case here. And so that already sort of concludes the part where I wanted to show you the structure. I know this is something that is a little bit abstract, but it's very dear to me because it shows what a comprehensive system you can build with R. You can build a very, very comprehensive system with R that orchestrates all your services and all your tools. And you can also use the right tools exist to make this manageable with version management, with unit testing, etc., etc. And you can build a very nice project with this. But I realize this is all sometimes a little bit dry. So we will now go and look at what this actually looks like in the R console. So I will quickly close this. Can you all see my R console? All right. I now have the challenge of putting the Zoom toolbar somewhere where it doesn't block what I actually want to show you, so I can see it as well. All right. So the last thing I talked about is I talked about this Eddy service that records all this data and that allows us to very quickly get this data back into R. And the question is always, if I have a lot of data, if it's a pain in the neck to get at it, then it's no good. It has to be easy to get at it. It has to be easy to work with, and it has to arrive quickly. If I have to, I'm not a patient guy. If I have to wait for my data, then that's not great. So we have this package, which is called Eddy2R, which has got a function, load ticks. And I tell it, I want to start on the 13th of May. I want to go to the 14th of May on the German Stock Exchange, etc. in Frankfurt. And I've just picked out one instrument pretty much at random. Please go ahead and load this for me. And it does. We see the logging starting now. It starts loading data. And it took a little over 3 seconds. 4 seconds in total, maybe, and it's loaded 36,571 rows. So that's the ticks I've got for this instrument. So that's already pretty neat. Yeah, you had to contact the cloud. All our cloud workers are dormant, so because they cost money, of course, when they're active. So they're dormant. So they got triggered when I sent the message. They got revived. They very quickly woke up, read the data, found the required data in all the terabytes and terabytes of data that we have, found the required data, retrieved it for me, and streamed it through the RESTful API to the R session. I have one little problem with this, because if I want to analyze this, because as I said, this is tick data. So this data looks like this. Somebody, like when I explained the limit order book to you in the beginning of the talk, Yeah, I said, okay, look, somebody adds an order for 1,000 shares on the ask side at a price of 13.04. And somebody adds an order for 180 shares on the ask side at a price of 13.03. And somebody cancels some, and at some point somebody is going to execute a trade somewhere. And if in the middle of the day I want to know, yeah, but what's the actual price? What is the best bid price and the best ask price at this time of day? I can't tell. It doesn't tell me. I only see the orders. In order to tell what the best bid and best ask price at this moment in time are, I basically have to follow the entire history of all of these orders and aggregate them and see what's left. And then I see what are now the best bid and best ask orders. And processing stuff sequentially in R, well, you know what it's like. If you have a for loop with 10,000 iterations, you can go have lunch before that thing is done. So, but RCPP comes to the rescue. Yeah? R has this very nice, I'm not sure how common it is that people use this. R has a very nice interface called RCPP, which allows you to write C++ code or C code in, for example, RStudio. If you have a decent compiler installed that matches your all the required versions, like Clang, for example, you can also have syntax highlighting and everything in RStudio. And you can compile it at runtime even. Yeah? And it's really easy to use, much easier to use than the somewhat baroque C interface of base R. And in that way, you very quickly, you can very quickly use C to handle the stream, and then sequentially processing all this is no longer very difficult. So I've changed from load ticks to load levels in my call. So now it'll load all the ticks in pretty much the same amount of time, but it'll aggregate what is the best, second best, third best, fourth best price, etc., 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 on the fly and give me the data. So it's taking a little longer. Yeah, in total, it's taking 13.3 seconds, and it has delivered 6,281,000 lines of data in 13 seconds. Yeah, if you use anything like any current SQL interface in R, to load 6 million lines out of an SQL database that is located on the same machine as your R code, I think you would struggle to read 6 million lines in 13 seconds. So having this raw data in the cloud, streaming it to our R session, and then processing it with RCPP and basically reconstituting it on the fly is incredibly efficient. It gives you saw how this went. It gives you a very smooth experience. You don't have to wait a lot. It tells you what it's doing. It's done very quickly while we're talking about this. Now you have something that you can analyze. You can make a plot with ggplot, for example, which I highly recommend. I think it's the best graphing library I've ever seen. So a bit of advertisement for my second favorite package there. Favorite package, of course, data table. And so you do a plot, you see what how the best bid and best ask price changed throughout the day, and you've loaded all of this in not even 14 seconds. Very smooth experience. I think our technology and development teams have done really great work there. It's something we're very happy with, and it shows that you can use something like the cloud really nicely and smoothly within R, and you can integrate this very smoothly. Something else that we are doing that I'm extremely happy with is a new package that our data team has built for us that allows us to actually create elastic compute instances. So if you're familiar with Elastic Compute Cloud, with Amazon's cloud, you can basically instantiate virtual computers pretty much on demand. You can build your virtual web server, virtual database server, and you get a sort of second precision. You get it. I'm sorry, I'm just checking my time to make sure I'm not running behind. You get a sort of a second precision billing as well. Yeah. And so we are using.
We still have 15 minutes. Sorry.
Yeah.
15 minutes. So
I think we can manage.
Yeah.
All right. Thanks, Peter. So we're using R6 classes here. Yeah. If you know R is usually more of or it's usually not so fond of object-oriented programming. They use this generic function programming, which is very foreign if you're coming from a C or JavaScript or Java background, or also from a Python background. If you use R6 classes, is also something I recommend trying. If you come from that sort of background, then you can do pretty much conventional message passing object-oriented programming. So something with object. It's not object dot function, it's object dollar function, but still we're very, very similar there. And so our data team has built us here an object. It's called an EC2 instance. I call the constructor with new, and I have to tell it very little. I tell it a name, which is in this case our meetup demo. I tell it the instance type, which is what we have to tell Amazon, which basically tells them how many cores we need, how much RAM we need. I give it a lib tag, which basically tells it what Docker image I want to load on there, which library versions do I need, what databases should this be equipped with, what services should run, and how much storage the hard disk should have. And then I can give it any old R expression. I've given it 1 + 1 here. Yeah, I could start a backtesting job. Yeah, we have very sophisticated backtesting for our algorithms. Yeah, I showed you we capture all this data from the exchanges, and we can start a simulated exchange and replay all the exchange messages, and then have our strategies trade in this virtual exchange, thinking it's the actual thing and behaving just like in the real exchange. That's of course very resource hungry, and I could start this in an instance like this. And so I could start a job without resource sharing with my colleagues. And so what does this mean? R5 2x large. Well, I can go to the Amazon list here. They have all manner of different instances. Yeah, I can choose an instance class up here, and they're all optimized for something else. R5 2x large tells me it's got 8 virtual CPUs and 64 GB of RAM. Yeah, if I think, oh well, that's not a lot. I have something I want to simulate millions of public orders and hundreds of instruments. Give me something bigger, no problem. R5 24x large. I want 96 CPUs. I want 768 GB of RAM. I get myself a 24x large. I create an instance, and now I can fire up R in this fully interactive R session, which runs completely insulated in its resource usage from anything that my colleagues use, has 96 cores, almost 100 GB of RAM, and can run very powerful jobs. So resource insulation is a very powerful motivator here. Yeah? We want to have this resource available and not wait until RAM is available, and not always have our jobs crash because somebody else filled up their RAM with their jobs, or wait until it's our turn in the queue because we're impatient people. Yeah? The additional advantage is that it really, really helps with debugging, because I can have an interactive R session running in there. And so instead of being in this situation where my session crashes, and now I have to copy out all the logs, and I take screenshots, and then I make a zip file of this and pass it over to our developers, I can just pass them the IP address and the username and password for this Elastic Cloud, for this Elastic Compute instance, and they can immediately connect to my problematic R session. Maybe it's even an R session that's hung up. They can SSH into that thing. They can connect their debuggers. They can see what the processes are doing. And this really, really helps to trim down the debugging and error hunting process. Or at least we hope so. It looks like it will. This is a very new system that we've only just gotten live, which you can tell by the fact that I'm super excited about it. Yeah, so this is the really cool, exciting new toy for me. All right. So these are two very important tools for us. And so now we can create the computational muscle, and we also can get at the data. Excuse me, but that in itself is not enough. We have to do something with this. Yeah? Otherwise, what's the point? And to do something with this, we've got a package called MTI Conduit. MTI, if you see this abbreviation, this is a shorthand for our research team. This is a shorthand for modeling and trading ideas. And Conduit here is a synonym, of course, for pipeline. And let's start the logging. And MTI Conduit is a system that we use to allow us to build very modular machine learning pipelines. And that also makes it easier to work on these with multiple people at the same time without always having merge conflicts, etc. And so the first thing we have to do before we start machine learning, we have to define a data source, which we do with our data loader system. And we tell it here we want 7 days of data. It starts 7 days ago and yesterday for the German stock exchange. And we tell it we want an executor. An executor is a little bit like a canvas that will host your machine learning project. And from this point forward, you will see that this is very heavily inspired by ggplot, in the sense that we're trying to basically we once create the canvas with which we work, and now the individual working steps that we want to perform we add. with an operator. So I have my executor, and now I have defined what data I want. I can also define multiple data sources, no problem. I don't have to use just one data source, but we're doing a simple demo now. And so I can now I need to split this data into test and training data. So I add a splitter. Nth day means every second day now is a training day. If I put nth day equals 3, then every third day would be a test day. So it would be training, training, test, training, training, test. If I put a 2, it's train, test, train, test, train, test. We have a bunch of other splitters. We have random splitters, sequential splitters, pretty much anything you want. You can just add it in here. We want to do supervised learning. So we have a label maker that basically labels every trade according to whether we think it was a good trade or not such a good trade. Let's add that in. We need that. Now we would start adding a bunch of features that tell us whether this is a good trade or not. I'm obviously not showing production grade features here or features with which we make money. I've just made a little function that adds in a bunch of mock features called feature 1, 3, 2, 4, 5, 1, 2, 3, 4, 5, 6, which are loosely correlated with whether this is a good indicator, whether this is a good trade, I'm sorry. And then we need a model. And so we could use XGBoost model. I could create a logarithm regression model. Pretty much anything I want, I can add in here. I can put in PyTorch models or TensorFlow or whatever. I just add it in. And now I've defined my machine learning project. I've defined the data. I've defined a splitter. I've defined that I wanted to build labels for me. I've told that we have features. What is the model I want to train? Sometimes when you build more complicated processes, so these were just 4 steps. Our production grade pipeline has something like 200 steps. Of varying complexity, so you want to be able to see what you're doing, so you can render this thing in the viewer. And now you see your executor currently contains these 4 nodes, which will be executed sequentially. Okay, I can close this and open this with this structure. Doesn't help much. If you have a bigger, more complicated structure, this allows you to also have sort of child nodes and composites, and then close and open this up 2, 3 layers deep, and to just inspect the pipeline that somebody else may have built. Your colleague has built something and says, I've built this cool thing. And it's much easier to figure out what the hell is going on if you can quickly look through this and see what's actually happening. Rather than reading pages and pages of code, you render this system once with the salient atomic steps here shown, and you can flick through it and see what's going on. All right, so we've defined our machine learning project. We've rendered it and looked at it, and we think it's a cool idea. Now the question is, how do we get it to do something? And first of all, to get it to do something, we tell the executor to prepare itself, which basically means it starts loading data. We see the log messages appearing. This will take a minute because we're loading quite a lot of data from the German Stock Exchange. And although this is just a mock data set, as I said, not a production data set. And yeah, so basically it's loading the data, and once it's loaded, then we can execute all these steps. And one other really good reason for having all these individual steps, so every working step, it looks here like we're adding in a function, but basically these are convenience functions that create stateful R6 classes. So they create fully fledged objects with all the state awareness that comes with it. I see that the preparation is through. Yeah, and that means that you can also restart individual pipeline steps, and I'll show you what that looks like in a minute. So first of all, we've loaded the data, so now I tell it to fit the pipeline, and I want to run 10 rounds of our model, 10 iterations of our model training. And you start it, every node starts giving you feedback, telling you what the hell is going on, what it's doing. Now it's passed control to XGBoost. XGBoost does its training, does a little bit of incremental work there, and in the end you get a fully functional, fully fitted XGBoost model. It tells you here, done, applied fit to all nodes. If something had crashed, it would immediately tell you what the offending node was, at which stage it's crashed. So it's very nice, then very easy to find this in your structure. Now we can plot the convergence. So now I've got to move the video again. And now we see here, after how many iterations, red is the training data set, and this blue-greenish color is the test data set. And we see how the performance of the model improves with training iterations. And at some point it goes, no, this is enough. We can't go any further. So the training saturates. So in these few steps, we've now basically configured a complete pipeline with a data loader, splitter, label maker, XGBoost. I can use the same pipeline and just change out the XGBoost for a logistic regression node, for a deep learning node. I can fit it again, nothing will change. Yeah? Even with the data already loaded, I have functionality to now replace individual nodes in the pipeline and replace the model with the deep learning node, for example. And I can also go ahead. So one of the cool things I said, every node is basically a fully functional R6 object. So if you now pay attention, not to the code up there, but to my console, I quickly empty it. So the executor holds these all by name. So I can address the XGBoost classifier. I address all its individual parameters here and all its functions. I can also get the fit state to extract the XGBoost, the actually trained XGBoost model. I can find what parameters it ran with, etc., etc. But I can also restart it. I can say, actually, that was interesting, but I wonder how good the model would be with, I don't know, a different learning rate. Yeah, I can mess around with eta. I can mess around with the number of iterations. Let's just do that for now, and I can restart the fit. And if I do this, the problem may be that some of these nodes make changes to the data. And what do I do then? I can tell it to reset true, and then that means any node. Yeah, so if I say exact fit and I give it the node name, it will only fit this node name. And that means that if I tell it reset true, then any changes made by this node or any node coming after it will be reset and scrubbed from the data. So you can just rerun the entire pipeline without any trouble. Yeah, you just want to restart your training. You can save so much time. Yeah, maybe the pipeline looks really nice. You've loaded your data, everything's ready. You notice, your split was not good. You need to make changes to your split fractions. You don't need 30% test data. You only need 20%. You change the splitter. You reset the relevant nodes. The pipeline handles it for you. Yeah, so that is stuff that's very exciting to me. And I guess the question that everybody who often works with large amounts of data and large data sets would ask is, how do you redo? How do you undo all your changes? That is a question that I always find very complicated, to track changes and undo them. The second point that I notice is, and that you probably notice, is I've shown you a lot of really exciting stuff. But this is all stuff that I can do because I've got a very powerful, very high performance data and development and technology team supporting me and building these really cool libraries for me. This is not something you can just replicate at home. So I want to give you something where I can show you some of the techniques that we use, show you some of the basics, and maybe show you how you can replicate some cool stuff at home. Yeah? So that is what I want to do now. And we will start with, so this is something to do with non-standard evaluation. And the reason we're looking at this is basically this undoing of changes. Yeah. So in an ideal world, as a data scientist, any operation on our data, we would want that to be logged. Yeah. So we want to know that it.
Daniel, yeah. I like beforehand, you still have 10 minutes.
Yeah, thanks. Yeah. We know that the data, we want to know that the data was changed. We want it to be transparent. So we want to know what the change was. We want it to be traceable. So we want to know who made the change, not who, what user, but who, what function. And we want it to be non-destructive. We want to be able to recover the original data. And the key to this in R is non-standard evaluation. Non-standard evaluation is something that you can do in R very easily, and that's very hard in other languages. And it basically allows you to suspend execution of your code and suspend interpretation, and store any expressions for later, and then mess with them, look at them, and execute them at a later time. And I want to show you what that looks like. Basically, let's create a data table here. Sorry, I'll quickly empty out my console, so that's a bit easier to follow maybe. So let's create a data table. This looks like this. We have one column X, 1 through 10. And now we can increment X by 1. That's no big deal. Now it goes from 2 through 11. All right, but instead of putting this expression in here into the data table, I can also store it with using the rlang package. This is a public package on CRAN. I highly recommend that you learn to use this. It's great fun, if nothing else. And you can capture this expression for later use. Yeah, this now looks like this. This is a living R expression, not a string or something, yeah, in the global environment that is not being executed at the current moment. What could I do with this? Well, I could, for example, have a function, and this function I could pass a data table and this object, which is called a quosure. And the function would then apply the captured expression from the quosure to the data table. Yeah, so at first, it extracts the current expression, and then it evaluates it in the context of the data table. So I can do something like this. Apply expression. I pass it my data table, and I pass it the operation that I stored. And now if I print my data table, we see it's incremented again. Now it starts at 3 and not at 2. So at first it doesn't sound terribly exciting, but of course it means that anytime somebody makes a change to my data table, instead of applying it, I can just go ahead and store it and keep my data table unchanged. And every time somebody makes a change, and only when somebody says, okay, now give me the process data, then I make a copy of the data table, apply all these processing steps, and give it to the guy. And in that way, I can treat these things like layers, like Photoshop layers or GIMP. Yeah, think of your favorite photo editing software, GIMP, Photoshop, I don't know. Yeah, you have your photo, your raw image, you start editing in a layer, and you can always undo the layer, look at the raw image, you can switch the layer on again, you can switch it off again, you have 10 different layers, and you can do this as well. And if you build a whole package around this, this is what we call flex table here. And so you can see here, I create a data table with an X and Y column. I turn this into a flex table with the sFlexTable command from my package. And now I tell it, okay, get DT, get data table, and I see the 2 columns and an automatically generated row ID. So far, not terribly exciting. However, if in my flex table, just like I did with the data table before, I increment X by 1, and now I have a function that also doubles the Y column. This is called double Y. It just says Y equals Y times 2. So all the data has changed in the way we expect. X is incremented, Y is doubled. Now I can tell it, okay, get layers, like in Photoshop. And it tells me down here, layer 1, X has been incremented by 1. Layer 2 was Y has been replaced by Y times 2. And this has been done in a function called double Y call. And you can exactly tell who has made what changes. So that is very, very exciting to me. But you can do even more. Let's say this is something that you've painstakingly built over the hours, and now one of your functions does something stupid and overrides one of your columns of processed data with all zeros, and you keep working, and you look at your data and you say, X is all 100, that's not right. What the hell happened? You say, show layers. You look at all your layers, and you find the offending layer very quickly. X has been set to 0. You say, okay, that's not right. I want to see whether the data looks okay without that layer. You tell it disable layer 3. And now all the changes, layer 1, layer 2, and layer 4 remain. And layer 3 has been changed. And now my X goes from 102 through to 111. And if I tell it, show me the layers, then it shows me all the layers. And you see here the deactivated layer is grayed out. I can bring it back. I can switch it off again. Yeah, this is something I find incredibly cool. Yeah, this is a lot of fun for me. And one thing I want to point out at this point, we've never done this before. This is a package. I said you can do this at home. You can. We are open sourcing this flex table package. You are the first people to hear about this. Yeah, exclusive content here. This is on Codeberg. So I have to get the Zoom toolbar out of the way again. Yeah, this is the address. I will quickly post this into the chat. There's a lot of stuff going on in the chat. I will just post this in here so anybody who's interested can take it from there. Yeah. So be aware, this is something that we think is incredibly cool. This is not something that we offer as a product. This is something you can use to play with, you can use to experiment with. Yeah, we really hope you have fun with this. There's no warranty of any kind, and you will not get any support. Yeah, you get in trouble with this, you're on your own. Sorry. Yeah, this is just sort of as an essay for you to try to do some cool stuff. We really hope you have fun with this. If you do something cool with it, drop us a line. We'd love to hear about it. But besides that, I'm sorry, we do not offer any kind of support or certainly no kind of warranty for it. Yeah, it's still, this is only used by the people who build it, basically, who know what works very well, what doesn't work so well. Yeah, and yeah, so have fun with it. Don't rely on it. It's my message currently. This is why we haven't put it into CRAN, for example. This is just for you to take something fun away from here. So this brings me pretty much to the end of the talk and to my conclusion slide. A couple of conclusions. R is fully capable of orchestrating a complete and powerful research ecosystem. You have the same software development troubles you have anywhere else, but R is perfectly capable of doing this. You can build a professional and robust CI/CD system and release process using pretty much only open source tools, GitLab, TestDat, Roxygen. They're all great tools. They're available on CRAN. TestDat and Roxygen are. I highly recommend them. If you have somebody who knows what they're doing, and at this point you will of course probably have to step outside R for neat cloud integration, but then you can get very smooth cloud integration, a very good user experience for pumping data from the cloud into your R session. And it is possible to leverage R non-standard evaluation, NSNE is the abbreviation here, non-standard evaluation functionality, to build an analysis framework with completely immutable data. Usually this is very difficult, because if you have a large data set, immutable data, if you do front-end development, you do React, that is totally normal. Every time data changes, you just copy the entire data set, and if somebody says undo the last step, you don't worry what they changed, you just delete the last data set and step one back. If your data set is like 100 gigabytes large, you can't do that too often before your RAM overflows. But with R non-standard evaluation, you can do this, and this is not easy as far as I'm aware with other languages. And this is also very cool to mess around with the interpreter steps and really look at what your interpreter is doing. So, and that brings me to my actual conclusion. Building big projects with R is not only possible, but it is effective and it's fun. R is pretty cool and allows you to do some really cool stuff. Also, if you agree, we would totally love to hear from you on the careers website. I got to do a little bit of self-advertising here. Please check out sswtrading.com career. We're always looking for great people, especially we're always looking for great people who know R. We're always looking for great software developers. You don't need to know R. Currently have a bunch of positions open: quant developers, Python developers, R developers, Java, C++. So if you're interested in working with us, I have a lot of fun here. It's great colleagues, it's a great environment. You get to do fun talks with Peter and Malte. So then I would totally love to hear from you. Please do this ideally via the careers website. And if this is where you heard about it, then maybe tell them about it so that we know that these talks actually generate interest and that people don't go. So, all right. So that's it from me. I think I managed 45 minutes.
You are totally within the limits, and I think I can speak for all of us. We are totally blown away by this, how to call it, a bouquet of amazing stuff. So it was kind of a series of wow, cool. So
I'm glad you
thank you very much. So I think we now will have a break, 5 minutes. So you can relax a little bit, and everyone else can kind of cool down a little bit. And I have noted down some questions coming from the chat. And then we start talking, doing some questions. There are, I think, a lot of them. And yeah, see where this goes. So
cool.
Thank you very much.
Yeah, thanks a lot. Okay, I will see you again in 5 minutes then.
Yeah.
All
Perfect.
right.
So everyone else, you can post your questions in the chat. As I said, I already noted down some questions. I'm not sure if we can go through all of them, but we will see how we can manage.
Hast du all die Fragen aus dem Chat eingesammelt, Peter?
Ja, so grob, glaube ich schon. Ich habe es auch offen. Also ich sehe, glaube ich, die letzten sehe ich noch vor mir.
Cool.
Okay. Daniel, are you ready?
Yes.
Okay. Thank you very much. There are some questions like which are more technical, maybe a little bit also smaller questions. I'd like to postpone them a little bit and maybe go more into like getting a better understanding how you people work at SSW Trading, because I think often like what you find in companies is like either one model where you have like data science team, which are a team, and then they spread out into the company doing a lot of stuff at different ends. Or you have something like you have a loosely coupled team and they are embedded in separate teams in separate parts of the company. And I think you guys are very, very different, right? You are more like part of the product or something. Maybe you can say something about how you're embedded, how you work with within the company or something like that.
Yeah, so, okay, cool. I guess you're right. This is very different from what you would see at most companies at SSW, because in a way, the data science is pretty much the entire product. Now, what we do is we trade, and we trade using our algorithms, and the algorithms are basically powered by our analytics and our data science. And so we all work very, very closely together, which is great. This is something that has grown even more close, I think, over the last years, the working relationships between our technology and our data science departments. So, yeah, so basically, I'm sorry, taking half a step back. The way this works is we have three separate groups that do data science in some way or another. We have the trading data, the trading analytics, and the research groups. Which all do sort of very similar things, or they work on different ends of the same problems. Yeah, the trading data group especially are the group who put a lot of work into providing us with all these really cool R packages and building a lot of the very exciting infrastructure that I just showed off. But all of them together basically we all together build the tools and the methods for analyzing our algorithms and then coming up with ideas to making them better. So the sort of things that we do are either we try and find ways to determine where our algorithms don't have the optimal settings, which involves but then basically being able to dig out our own trading data, compare it with the public data, see where maybe we are missing some good trades, where we would have more potential, and try and figure out how we can sort of goose more performance out of the strategies the way they're running. Or we work together because somebody has a cool new idea, and we all work together to basically build a proof of concept, to build an analysis that shows that this idea ought to work, and to then build sort of a prototype that can be made to try and trade. And at that point, then we have to bring the technology department on board, who are those of our colleagues that don't do so much data science, but they do the hardcore programming. Yeah? The guys who know how to keep your cache line hot, how to not go to RAM too often because RAM is too slow. Certainly you can't load anything from hard disk. Yeah? So the really hardcore guys in the technology department who write the strategy code. And so in this way, pretty much, but these ideas can come from anywhere. And usually they come from somewhere within these three teams that somebody says, I've had this idea, how can we make this better? And so we're not so much a service for other departments in the company, but we are really trying to provide the innovation and the inputs and the momentum to bring the company forward. So the agenda that is being followed by those teams is pretty much set by those teams and not by some sort of different business arm of the company.
Yeah, that's pretty cool. I mean, this is I think quite unique. Not this is something which you don't often find elsewhere. And I think it's very interesting. Maybe another also a little bit broad question. I mean, I knew kind of what to expect, right? I knew beforehand that you're heavy R users and that you already invest a lot into infrastructures and stuff like that. But I think maybe for newcomer, you might think like, oh, they do so much stuff, and how can they come up? How can I compete? So maybe you can say one or two words about like how much time it took to come to all this, like to have several own proprietary packages and to have cloud and to have a lot of ideas how to handle data and to have a solid software development process and all
right,
this stuff.
Right. So this took, yeah, you're right. So this took a lot of time and effort. I started at SSW in 2015, which is pretty much when we also really started using R. And at the time, I was pretty new to R. I'd used it once or twice before, and my R code was pretty awful. I have to say, I think I've probably written some of the worst R code that is still in production in the company. But so you shouldn't be daunted, because R really gives you great tools to learn with and to become productive quickly. If you look at particularly data table is one of my favorite tools there. If you try and just learn to master data table, you can wrangle data and manipulate data. You can learn to do this so well and so quickly. But to build this ecosystem that you see here that we have is, of course, something that is a great team effort that has been built over the years. So this is something that we've built on every year and every month and every week. We've tried to improve this since 2015. And along the way, our own expertise has grown considerably, but we've also added a lot of people. In the beginning, there were 2 or 3 of us writing this kind of code. And now there's maybe 8 or 9 people who are serious R coders. And we have a lot of, as I said, we have a lot of support from a great technology department who are really great at all the other aspects of software development, who build these really great interfaces into the cloud for us. So that's an enormous advantage that we have. But also we have this advantage that in a way that our users in a way are the people, the traders that we have. And also there we have a really great working relationship with those guys. Yeah, so we have very sophisticated users. And we don't have to spend a lot of time trying to explain to somebody that they have to switch on their computer. So we have a lot of really great colleagues at the company, and that helps in getting stuff done. I mean, we also have phases where you have a lot of technical troubles and you say, oh my God, every time I turn around, I have another technical bug. You have phases like that, and then you work through it and you fix your stuff, and then it works again. And to build something like this takes a lot of team effort. But then if you're an individual data scientist, maybe you're a freelancer, that's not really such a big problem for you, because really, if you're a small team or an individual, then it's very unlikely that you have to wrangle 2 terabytes of data. You probably have a very different class of project on your hands. As also the projects we are doing are enterprise grade, and we have an enterprise grade system, I guess is the message. And if you're doing, if you have smaller teams, then you do different kinds of projects, but you can do really great stuff with just base R plus 2 or 3 packages that you can load from CRAN.
Yeah. So yeah, talking about an enterprise grade, there's always kind of the question like build or buy, and from what I see, there's a lot of customized stuff, a lot of self-developed stuff. Like, so is it something like you I don't know, you kind of replace the R environment, or are you still standing on kind of the shoulders of giants? So how much are you using like only your own stuff, and how much are you also using stuff which comes from CRAN, from RStudio, from wherever, like from the community, from the outside? So maybe.
Yeah, so that's a great question as well. I think we use base R plus, I said, 3 packages is, I guess, 60% of my time or 70% of my time. I mean, I use these packages here, especially our data loader packages, of course. I use the stuff that we've built ourselves just because we've got so many different databases that are distributed over many different servers, and managing that by myself would just be a nightmare. So we've just abstracted this away in our data loaders package. But especially when I'm working on a new idea, I'm prototyping some new concept. Generally, I load my data, and what I need is data table. I need ggplot, yeah, and I need base R and a couple of lists and list manipulation things. And with that, I'm totally happy. Yeah? Mm-hmm. You can get 90% of the way with those. A lot of the infrastructure that I showed you again is not so much wouldn't be of concern if I was working by myself. I mean, flex table is cool to have if you work by yourself. It's nowhere near as essential. It's really essential if you have a code that has been written by 6 people that has grown over 2 years and consists of 200 different functions. And now some transformation happens that you don't understand. And how on earth do you find out where your data broke? Well, you use flex table, you check where your layers changed, and you can try what happens when you reverse certain transformations. Then you really need that sort of stuff. But yeah, if you are working by yourself, it's nowhere near as essential. And then data table, ggplot, base R, and you can do a lot of really great work with that, I think.
Yeah, cool. I'm talking about. I'm kind of now switching to going more into the questions coming from the chat and more the technical stuff maybe. Talking about data table, there was a question. If the stuff you're using are, I'm not sure which things you showed were faster than data table. Maybe.
No, they're absolutely not. Data table is blazingly fast. Data table is very, very fast, and there's some really very talented people working on data table that write absolutely fantastic code. And actually, flex table uses data table under the hood. Yeah, what we do is we just memorize the individual steps and the individual expressions, and we allow you to make sure that rather than manipulating data table every time these manipulations come and changing your raw data, we just memorize all the transformations and we play them back. It's really pretty much exactly what I showed you. Yeah, we capture the expressions and we store them somewhere, and then we apply them to a data table. And so it's actually quite considerably slower than data table. Yeah? If you do it like this, it's just the amount of time data table is so fast that even losing quite a lot of performance there is totally worth it to me for having this added functionality. In some cases, there are some cases where we use bare data table, and we're also very, very happy with that. But in cases where I have data sets that go through a lot of complicated transformations, I prefer using flex table. But it's not faster, absolutely not.
Okay. There is also the question like your QEC2 package, if it's based on AWS .EC2 package, or is it homegrown, home built?
I think the vast majority of that is home built by our technology team, and I have to tell you honestly, I cannot answer that question.
Okay.
Yeah, this is a great package. As I said, I meant every word of that. Yeah, this is a very great package that I love to use, that the data team has just finished, and it provides a very smooth integration into your R environment. And it's my newest toy. I love it, but I don't really know what's under the hood there. With most of the other packages I showed you, I've had a hand in building them. With this one, I've been totally out of the loop.
It's okay. Probably they did a good job that you never have to dig into it or think about it. There was a question about doing analytics, about backtesting and simulation and trying to find it. And the question was like, if there are not maybe some problems when you do like backtesting and simulation on historical data, because you are part of the system. Like, so maybe there are some endogeneity problems or something like that. I'm looking for yeah, how does testing with simulation plus historical data work? Don't you influence the market with your own trades, which are, parentheses, which are not represented in the historical data? Do you have some comments or something?
Yeah, sure. So yeah, in terms of influencing trades, there's two things to consider there. So this is very astute observation. Yes, our own trades are of course part of the historical data in a way. Yeah, because most of the markets where we run simulations, as I said, 30,000 instruments, we're pretty much in all of the instruments of interest. We are pretty much always there, and we always quote, and we always send orders, and we always trade. And anything you do has an impact on the market. So of course, in our simulations, we are simulating a world in which we also have to compete with ourselves to some degree. And I can address that issue in multiple ways. One way can be, I can say, sure, let's see what happens if there's an identical competitor in the market. But I can also, for example, in my simulation, I have perfect control over all sorts of parameters, for example, the latency. And I can just give my simulated strategy a little bit more latency than my real strategy, a little bit less latency than my real strategy, to make sure it always trades ahead of the real strategy, so it doesn't have to compete with itself. Having said that, one thing you're right is, of course, in a real situation, the market would react to everything you do, and a simulated market won't. This is a fact of life. Simulations in that way are necessarily imperfect. We're making them as good as we can. We've put a lot of work into getting them to as high precision as we can, but there's of course always more you can do, and there's always some remaining imprecision because you have no idea what the other players in the market would have done or how they would have reacted to you.
Yeah, thanks. There was also some discussion about the operators used in your code examples. Like there was no Magritte pipe operator used, but the plus operator. So is there some particular reason, or is it?
No good reason. the reason is, as I said before, I really like ggplot, and I found this way of working with objects very intuitive. So when I first started thinking about how do I want to organize my own system, what do I like, what way of working in other packages do I like, and what works well for me, I thought about ggplot. This worked, so that is what I replicated. I also use Magritte quite a lot. It didn't really apply here because, as I say, for the combination, I used the plus. We could have probably just as easily used that. It requires you to organize your code a little differently, because for using Magritte, they have to be functions that act on each other. And I'm not sure whether you can decouple it quite as neatly in that case. But
yeah, you gain a little bit of flexibility, right, by using your own operator, because
So, but mainly there was no. It's not like we sat down and said, okay, what's the best design decision here? But rather, when I started building stuff like that, I was like, okay, how do I like to work? I like to add stuff together. It seems simple. It seems easy. Also, I know how to do that in R. I knew how to overload the plus operator, no problem. And so that's how I started, and then that stuck. It worked.
Yeah. Okay. Yeah. Well, totally fine.
Very unscientific answer. I'm sorry.
Yeah, it's a lot of things are usually just it was the first thing we tried, and it worked, and we stuck to it. Okay, let's see. There's a question. Do you have data quality issues because you only dump CSV files into S3? Or is it not an issue because the data format is always standardized? Do you dump CSV?
Yeah. So it's flat file. It's not really CSV. It's our own format, I think. But we have no data quality issues there. The format is very standardized. the data quality issues usually come not from storage, but they come from things like from recording the data. Because you are running a network connection for a very high intensity line, which has a lot of data flowing through it, and then if you miss a packet, then suddenly all the ticks don't add up to the right order book anymore. Sometimes you don't miss a packet, but the exchange drops a packet. Sometimes in one of the other servers, like in one of the UDP servers that serve these packets to you, there's an error. So that is usually the data problems are external to our pipeline, and we have very good quality assurance processes. In the past, we've compared these exchange data to data that has been recorded directly by the strategies, and we've made very precise comparisons, and we've been able to reconstruct our data from the strategy log data with a very high degree of fidelity.
Yeah, very cool. You said UDP, which means like you don't get any assurance that all the data packets are actually delivered.
Yeah, correct.
So packages can be lost because
and
it has to be fast.
It depends on the exchanges and the feeds that you're connected with. And there you already hear there's a lot of technical variability there. And our technology team go through quite a lot of length to make sure that what we get is standardized. But in the interface to the exchanges, there's much more potential for trouble because you're connecting to many different exchanges and everyone with their own idiosyncrasies.
Yeah. There's another question. Is your training backtesting environment only capable of using built-in R machine learning models? Or do you use also or set up your own packages, models? I'm not quite sure if I understand the question.
Right. So we are not only using built-in R packages or R packages. As I said, we can use PyTorch, for example. We can use anything that can be exported to any model that you can export in ONNX or Torch script we can run. Because of course, when we do the backtesting, and this is something that's really very important and that's very central to the quality of the backtesting, we do not backtest some R package or some R prototype. We backtest with our actual strategies. We have the actual strategy code, and we start a virtual exchange there. The strategy runs as though it was deployed in an actual real exchange. And what we do is we design the new machine learning models that make all the decisions, and that these machine learning models run inside the strategy. And of course, inside the strategy, I cannot run R. R would be far too slow. I can use R for analysis and for prototyping and for designing stuff and for training my models. But once I have a trained model and I want to do a backtest, this has to run inside the strategy in something much, much faster. And interpreted language is never going to be fast enough.
Thank you very much. There's another question. What is the role of traders at SSW? Aren't all the trades executed by algorithms? So why do you need traders? Why do you have traders?
Yeah, that's true. We need traders, and we're lucky to have some. I said earlier, we're lucky to have some great colleagues there in the trading department as well. We need traders, and they need to have a very large amount of technical expertise, because while all the algorithms run themselves and they make all the trading decisions, you still have large amounts of strategies trading large amounts of instruments on an exchange, and somebody needs to keep an eye on this and also manage this to some degree. Yeah, so you will be in the situation that you see that maybe certain exchanges start trading a lot on one side. I usually like to be two-sided, of course, not run too much of an inventory maybe. And so one exchange starts trading a lot on one side, and your inventories grow and your risk grows. And then somebody at some point needs to make a decision. Is this okay? Is this normal market behavior? Do I let this run? Somebody has to monitor this. Somebody has to monitor whether the behavior of the strategies is okay. And sometimes when strategies behave oddly and also start losing money, potentially, and an individual strategy might lose some money some days, somebody needs to look at this and observe the strategy in operation and understand whether what the strategy does is still sane, or whether the strategy is doing something really, really strange that we need to stop. Or whether also maybe somebody's trying to manipulate our strategies. And we need people with a lot of trading expertise that can sort of, our traders are a little bit more like pilots almost, yeah, that sort of look after this, the very complicated system that automatically runs a bunch of strategies, but it still needs a human pilot or human trader that understands about trading and orders and exchanges to monitor it and to intervene if something goes wrong, and to maybe give it the odd nudge. Yeah. Sometimes you have information that you say, okay, there's going to be a lot of volatility in the afternoon because Draghi is speaking, so maybe let's become a bit more defensive, or I don't know.
Yeah. Okay. Yeah, I think this made it clear. Is it possible to get some information on the database technology used in your cloud environment? Do you use a relational database or any kind of time series database or something like that?
Yeah, so we use, I mean, for most applications, SQL databases, PSQL, Postgres is a very good tool for us. It works really nicely. It's just that when you get to really big data sets, that you start to run into trouble, right? But most of our database tasks are solved with Postgres SQL. Well, you've seen sometimes we step out of this, in particular when it goes to stuff like loading instrument ticks. This is not data where we need complicated queries. We want all the data for a certain number of instruments and a certain number of days. You don't want any complicated outer inner joins, cross-matching, semaphore, I don't know what. So then you go to S3 system and flat files. And those are mainly the technologies that we're running for those kind of data analysis problems.
Okay. Maybe let's have a last question. I had it here. Yeah, how do you estimate transaction costs? Do you have your own methods, or do you use some third-party tools?
No, we account for transaction costs ourselves. I mean, in general, we know what a trade should cost. We have a fee scheme. I'm not sure I'm answering the right question. So whoever asked this, feel free to stop me if, or to signal Peter if I'm not asking the correct question, answering the correct question. But basically, we get a fee schedule from the exchanges, and we compute those fees ourselves, both on the data analysis side, and also, of course, we make sure that strategies shouldn't place trades that have no chance of ever earning their keep. So it's important to be aware of the fees, of course.
Okay, there's a clarification here. I understood the question in the same way, but the transaction costs is mostly, or the question was mostly about how trades will move the market.
How trades? Oh, I see. I'm sorry. Yeah. Okay. So market impact is a big topic generally in trading. Not so much for us, because what we do mostly is liquidity provision and market making, which means we post relatively small orders on both sides of the market, right? We're always trying to be in the order book. We're trying to be on both sides. And we give you liquidity. Market cost of execution through market impact. This is something that the big guys have. If you're a pension fund or a hedge fund or something, and your investment committee was meeting, and then they say, what we really need to do is we need more exposure in Europe, in European automobile titles. And then somebody, some investment bank maybe gets the job of buying, I don't know, 5 billion euros worth of European automobile shares over the next week. Those kind of guys, they of course have execution costs. They move the market. We ourselves, we move the market. We basically don't move the market, especially because we only trade passively, or almost exclusively trade passively. Sure, we also have some aggressive strategies, but mostly the market making strategies. They are very inconspicuous in the order book. They don't move it a lot. Now, somebody who trades directionally, getting large amounts, acquiring large amounts of a certain index, or if you buy for €1 million over 1 day or something, then you probably have significant market impact. Somebody who does liquidity provision like us, market impact is not a big part. It's something that we're aware of, but it's not a big part of what we need to deal with.
Okay. Thank you very much, Daniel. This was great. I think it was great for the rest of us, for the rest as well. It's a little bit hard with feedback, but there were some thumbs up and good talk and stuff like that. So yeah, now there's some awesome and thank you and very interesting coming in. So I think this was a success. Thank you very much. Very nice having you here. And for the rest of you, the